Hello friends, welcome to the video lecture series of partial differentiation. In this lecture, particularly the short answer questions we are going to discuss, which will definitely help you in university examination, because university examination will be conducted online examination and the only MCQ will be there. So very quickly, some short answer questions on partial differentiation we are going to discuss. In previous video, what is partial differentiation? Some descriptive problems we discussed. Now in this lecture, only MCQs we are going to discuss. It's very quickly. In standard format, I am not writing MCQs, question and options like that. In order to save time, the only hint I am going to give you. Find del u by del x plus del u by del y of the following functions. Okay, these functions are there 1, 2, 3, 4, 5, and I want del u by del x and del u by del y. Yes, del u by del x means what? Derivative of u with respect to x is partial derivative of u with respect to x, keeping y constant. Keeping y constant. Say derivative of log of x square plus y square is x square plus y square is argument of log, and derivative of log of x square plus y square is 1 by x square plus y square, and again derivative of argument of log is x square plus y square with respect to x, 1 by x square plus y square as it is, and derivative of x square with respect to x keeping y constant is 2x, and derivative of y square with respect to x keeping y constant is 0, because y we are taking as a constant term. So this is del u by del x we have found, del u by del x. Now del u by del y I am going to find. Here when you find del u by del y, differentiate with respect to y keeping x constant. Derivative of log is 1 by that argument, and derivative of argument again with respect to y, in the multiplication I have to write. So 1 by x square plus y square, and derivative of x square with respect to x with respect to y is 0, because x we are taking constant, and derivative of y square with respect to y is 2y. So this is del u by del y, and this is del u by del x. In examination, u will be given, and del u by del x or del u by del y may be asked. Okay, and the functions may be different in the examination. Now, here del u by del x and del u by del y I am going to find. I am differentiating with respect to x, keeping y constant. See, here y is constant now, and x is variable. Y is constant, x to the power constant. Derivative of x to the power constant is what? Derivative of x to the power n. Okay, this formula used in 12th standard, n x to the power n minus 1, where n is what? N is constant. N is constant. So y is constant. Derivative of x to the power n is n x to the power n minus 1, and derivative of constant to the power x. This is exponential function, Derivative of a to the power x with respect to x is what? A to the power x log a. This also you used many times in 12th standard. This constant to the power variable. The derivative of a to the power x is what? A to the power x log of a. Log of a. So this is del u by del x. Now del u by del y, take derivative with respect to y keeping x constant. X is constant, constant to the power variable. Now y is variable. Constant to the power variable, its derivative is what? Constant to the power variable and log of constant. Okay, we are differentiating with respect to y now. and y is variable, x is constant. Derivative of variable to the power constant is what? X y to the power x minus 1. So this is del u by del x and this is del u by del y. Now here also derivative of u with respect to x keeping y constant. Derivative of tan inverse function is what? 1 by 1 plus argument square. Is it? 1 by 1 plus this argument square. And derivative of the multiplication, derivative of y by x again I have to write. Okay. Now this means take x square as LCM, x square will jump in the numerator, x square by x square plus y square, directly writing, and derivative of y by x with respect to x, means y is constant and derivative of 1 by x with respect to x is minus 1 by x square, and then x square will get cancelled. This is del u by del x. Similarly, del u by del y you can find out. Derivative of tan inverse is what? 1 by 1 plus argument square multiplied by derivative with respect to y of argument y by x. Similarly here, x square will jump in the numerator after taking LCM. I am writing directly here. X square plus y square, and derivative of y by x with respect to y, keeping x constant. 1 by x is constant, and derivative of y with respect to y is 1. Here one x will get cancelled and only single x will remain in the numerator. This is del u by del y. Now take derivative of u with respect to x, keeping y constant and z constant. Z also appeared here. The derivative of exponential term is as it is. Derivative of exponential term is the term itself and multiplied by derivative of argument xyz again. This is equal to e to the power xyz as it is, and derivative of x with respect to x is 1, yz is multiplicative constant. So in this way, del u by del y will be what? E to the power xyz, and derivative of xyz with respect to y, keeping x and z constant. Okay, it will be x and z. Okay, directly write. Now, derivative of u with respect to x, derivative of u with respect to y here, del u by del x. I am going to write. See, del u by del x means derivative with respect to x keeping y constant. Here there are two terms of x. Means this bracket containing x and this function, this general function is also the function of xy. Function of xy means what? Sin xy, cos xy, xy raised to 1, xy raised to 2, xy raised to 3, like that, tan xy, in this way. Function of xy. But this function containing x, this function also containing x. To use product rule, because we are differentiating with respect to x, x is variable. Derivative of f of xy is what? How to write? F dash xy. Okay, multiplied by, and derivative of this argument xy with respect to x is y, plus f of xy, second function, the u into v rule of the derivative we are using, because we have the product of two terms, the product of two functions. Second function, and derivative of x square plus y square is what? 2x with respect to x. Here, del u by del y is what? This function containing this bracket containing y, this function also, this bracket containing y, or this function containing y. Again the same thing. First function, use product rule, because in both of the functions y is present. Derivative of f with respect to y is f of xy, f dash xy, and derivative of xy with respect to y is x, plus second function fxy and derivative of x square minus y square with respect to y is minus 2. Okay, so you may solve it for one more step. Okay, so in this way, del u by del x, del u by del y we have calculated. Here, find del u by del z of the following function. Only del u by del z I am going to find. So differentiate with respect to z, because del u by del z I want, keeping other variables constant, keeping x and y constant, That is what called the partial derivative with respect to z. The del u by del z, I am differentiating with respect to z only. Derivative of exponential is as it is, and derivative of xyz with respect to z is xy, because derivative of z is 1 and xy will be multiplicative constant. Here again, derivative with respect to z, keeping x and xyz constant. Here x square, derivative of exponential is as it is, and derivative of x square plus y square. Here I am writing, you can write it directly also, x square plus y square plus z square, and this equals e to the power x square plus y square plus z square as it is, and derivative of x square plus y square plus z square is what? 2z, because derivative of x square is 0, derivative of y square is 0, derivative of z square with respect to z is 2z. Now, derivative of u with respect to z, here in this function, derivative of log is what? 1 by that argument x cube plus y cube plus z cube minus 3xyz, and derivative of this argument with respect to z will be what? Derivative of x cube is 0 with respect to z. Derivative of y cube with respect to z is 0. But derivative of z cube is 3z square with respect to z minus derivative of this function with respect to z is what? Derivative of z is 1 minus 3xy is multiplicative constant. So you can take 3 common and the next step you can write. Now, here the question is like this. Okay. Here the question is like this. If x to the power x, y to the power y, z to the power z equal to c, then find del z by del x. Find del z by del x. Okay. Now del z by del x I have to find. See, here in this problem, we are differentiating with respect to x, and this explicitly z is not expressed, but del z by del x I want that z must be treated as a function of x. Z must be treated as a function of x. This when you differentiate with respect to x, z you have to treat as variable, because we are going to find out del z by del x. Okay, we are going to find out del z by del x. Is it? Now, taking log of both the sides, because we have variable, power variable like that, so taking log, I am going to simplify it. This function I am going to simplify. Taking log of both the sides, log of a into b into c is log of a plus log of b plus log of c. Then by law of logarithm, this x can be brought here, y can be brought here. Okay. Now differentiate with respect to z, keeping y constant. Okay, differentiate with respect to z, keeping y constant, because we want del z by del x, and z is a function of x. We have to treat. This is important. Now, derivative of x log x is what? By product rule, x, derivative of log x is 1 by x plus log of x, and derivative of x is 1. Okay. Derivative of z log z is what? Z is treated as a function of x. Again, product rule, z, derivative of log z is 1 by z and del z by del x plus log of z and derivative of z is what? Del z by del x. And derivative of log c is what? 0, because c is constant, log c will be constant and its derivative is 0. So I am going to simplify it. This x gets cancelled, 1 plus log x. Here, this z gets cancelled, del z by del x I am taking common. What will remain here? 1 plus log z will remain. Now, shift 1 plus log x on the right hand side. It will be minus. I am writing directly del z by del x is equal to minus of 1 plus log x, because I am shifting this on the right hand side, and bring this term in the denominator. So this is del z by del x. Here, this equation is given. Z is not explicitly in terms of x and y. So, we have to treat z as a function of x, z as a function. Here in all those problems, you were given explicitly in terms of xyz. U is explicitly in terms of xyz. U is explicitly in terms of x and y. But here, z is not, when the del z by del x is required, x is not explicitly expressed in terms of y and z. But we have simplified it. We have simplified this function by taking log and then differentiate with respect to x. Differentiate with respect to x here. Should not be z. Keeping y constant. The derivative of x log x by product rule is this thing. Derivative of y log y is 0 because we are treating y constant. Derivative of z log z is this one. Then x gets cancelled, 1 plus log x is remaining. Del z by del x is common, 1 plus log z is remaining. Shift this term on the right hand side and then take this term in the denominator of minus 1 plus log x. Okay. Now, if u is equal to, next short sum, if u equal to this, then the value of del u by del x is required. See, where a is constant, where a is constant, g is constant, and n is constant. Okay, these are the constant terms. I want del u by del x. I want del u by del x. Okay, so how do you find out del u by del x? If you look at this function very carefully, a is multiplicative constant, but this is the function of x multiplied by, this is also function of x. So we have product of two functions. Therefore, use product rule here. A is common because a is multiplicative constant, that is common. First function, product rule of the derivative. First function, derivative of sine is what? Cos. Right, and derivative of this argument nt minus gx with respect to x is what? Okay, derivative of nt minus gx, here I am writing derivative with respect to x I am taking, derivative of nt minus gx with respect to x, derivative of n and t 0 because we are taking derivative with respect to x, keeping other variable constant, means t is constant. Derivative of this is 0 and derivative of x is 1, minus g is multiplicative constant, minus g plus second function sin nt minus gx, second function, and derivative of e to the power minus gx is what? Multiplied by as it is into minus g. Okay. Then here you can take minus g common. Minus g I am taking common, e to the power minus gx also you can take common, and remaining terms you can write cos nt minus gx as it is plus sin nt minus gx as it is. Okay, this is del u by del x. Now here del z by del x and del z by del y is required to be found. Okay, here again z is not given in terms of x and y explicitly. This equation is given, but z is not expressed in terms of x and y explicitly. You can call it as an implicit function also, implicit functions of x, y, z. In this case, when you take derivatives with respect to x, the z should be treated as a function of x. When you take derivative of this function with respect to y, and when you are going to find out del z by del y, you have to treat y as a function of, means z as a function of y. Here in this case, z as a function of x you have to treat. Okay, these two differential coefficients are different. Now, what is given to you? What is given? Z cube minus xz minus 4 minus y equal to 4. This is given. Now differentiate with respect to x, because I want del z x keeping y constant, because z is a function of x that we have to take, because we have to find out del z by del x. If you treat z as a constant, the del z by del x will be 0. Okay, it will not have any meaning. Now, derivative of z cube with respect to x will be what? 3z square, and derivative of z with respect to x. Here, derivative of this with respect to x, z is a function of x and x is a function of x. We have to use the product rule. First function, derivative of z is del z by del x. The second function z, and derivative of x is 1, minus derivative of y, because y we are keeping constant, derivative of y is 0 and derivative of 4 is 0. Okay. Now del z by del x we have to find. 3z square del z by del x. Minus sign I am going to distribute. Means we are going to multiply the inside term by minus sign. This will be minus of z. I am shifting on the right hand side. Directly I have shifted on the right hand side. And when you take del z by del x common, that's what will happen? 3z square minus x equal to z. 3z square minus x equal to z. Therefore, del z by del x will be what? Take this bracket in the denominator. Del z by del x will be z divided by 3z square minus x. Del z by del x will be what? Z by 3z square minus x. Okay, here we don't have sufficient space. Then the last step I have not written. Del z by del x is z by 3z square minus x. Now in continuation, the sums already I have written in order to save time. If u is equal to log of x square plus y square, the function is given. Then value of double derivative we have to find is del 2u by del x del y is what? Del x of del u by del y. Okay, this is what? It is a derivative of del u by del y with respect to x. Now, find value of del u by del y separately, because it is required here. As u is log of x square plus y square. Take derivative of u with respect to y, because del u by del y is required here. Derivative of log is 1 by argument, and derivative of x square plus y square, derivative of argument with respect to y is 2y. Here, del x of del u by del y separately I found, I am putting a value 2y by x square plus y square. Is it? Now, we are differentiating with respect to x, keeping y constant. 2 is multiplicative constant, y we are keeping constant. Then derivative of this function with respect to x. Okay. Now, 2y What is derivative of 1 by x square plus y square? Derivative of 1 by x with respect to x is what? Minus 1 by x square. Derivative of 1 by z with respect to z is what? Minus 1 by z square. Like that, derivative of 1 by variable is what? 1 by denominator square, okay, with minus sign, minus 1 by denominator square multiplied by derivative of the argument again. Okay. Now minus is outside, minus 2y x square plus y square whole square is as it is, and derivative of x square plus y square with respect to x keeping y constant is 2x. Therefore, minus 2 into 2 is 4 x into y by x square plus y square whole square. Here, double derivative term we found. Okay. In examination, you may be given different function, and you will be asked to find out del 2u by del x del y, or del 2u by del y del z del x, like that. Okay. Find del u by del x, del u by del y, del u by del z if u is equal to log of tan x plus tan y plus tan z. Okay, next sum. Now differentiate with respect to x, keeping y and z constant, because u is explicitly given in terms of x, y, z. It is what? Log of, derivative of log is what? 1 by its argument and derivative of this argument with respect to x is what? Sec square x. Okay, because derivative of tan is sec square, derivative of tan y with respect to x is 0, derivative of tan z with respect to x is 0. Del u by del y, again derivative of this log term is 1 by tan x plus tan y plus tan z, because in argument y term is there, and derivative of this argument only, derivative of tan x with respect to y is 0, derivative of tan y with respect to y is sec square y, and derivative of tan z with respect to y is 0 again. Similarly, del u by del z, take derivative of this with respect to z, same thing again, tan x plus tan y plus tan z, and derivative of argument tan x plus tan y plus tan z with respect to z is sec square z. Okay, these three differential coefficients we found. Now, next up, find double derivative of u with respect to x, double derivative of u with respect to y, double derivative of u with respect to y and x. See, here del u by del x means derivative with respect to x keeping y constant. Derivative of sine is what? Cos. And derivative of xy, okay, you can write it directly. I'm writing indirectly here, but you can write it directly. Cos xy as it is, and derivative of xy with respect to x keeping y constant. Y is multiplicative constant and derivative of x with respect to x is 1. This is del u by del x. Now del u by del y also I am going to find. Derivative of sine is cos, and derivative of xy with respect to y keeping x constant is what? Like this, directly written. Now I am finding derivative of double derivative of u with respect to x. So this can be written like this. Okay, this derivative can be written like this. Derivative of u del u by del x we already found. See, y cos xy we already found. Now take derivative of this bracket with respect to x keeping y constant. Y is multiplicative constant. Take it outside. Derivative of cos is what? Minus sin xy. And derivative of xy with respect to x is y again. Okay, is minus y square sin xy. Minus y square sin xy. Now del 2u by del y square I want. So this can be splitted in this way. Del u by del y we already found separately. What is it? X cos of xy. We are taking derivative with respect to y, keeping x constant. X is outside. Derivative of cos is what? Minus sin xy. And derivative of xy with respect to y is x. So it will be what? Minus x square sin xy. Third, double derivative of u with respect to y and x. This can be written in this way: del y of del u by del x and del y of del u by del x we found. Del u by del x is what? Y cos xy. Here now, take derivative of this with respect to y. But here there are two terms in y. This term, this function and this function containing y. Use product rule. First function, derivative of cos is what? Minus sin, and derivative of xy with respect to y is what? X. Okay, this bracket, complete bracket, is the derivative of cos xy with respect to y plus cos xy and derivative of y with respect to y is 1. Okay, and this becomes minus xy sin xy, because x into y is xy and minus is there, plus cos xy as it is. So this is del 2u by del y dx. Here also, next sum, if z is equal to x square plus y square, here z is equal to x square plus y square by x plus y. Okay, this x plus y in the multiplication of z I shifted to right hand side. Now find del z by del x. Now differentiate with respect to I want del z by del x with respect to x, keeping y constant, because z is explicitly expressed in terms of x and del z by del x. See here, if you take derivative with respect to x, the x is present in numerator as well as in the denominator. They use quotient rule of the derivative, u by v rule of the derivative. Denominator, what is u by v rule? What is quotient rule? Denominator square. Denominator, derivative of x square plus y square with respect to x, keeping y constant, is 2x, writing directly. Numerator, and derivative of denominator with respect to x, keeping y constant, is 1. And this is equal to, you can simplify 2x square, 2x into y, 2xy, minus x square, minus y square, divided by the same thing. So you can simplify for one more step. 2x square minus x square is x square, plus 2xy minus y square is divided by x plus y. Okay, now del z by del y I want. Take derivative of z with respect to y, keeping x constant. Y is present in the denominator as well as in the numerator. Therefore, again quotient rule I have to use. Denominator square. Denominator, derivative of x square plus y square with respect to y is 2y, minus numerator, derivative of x plus y with respect to y is 1. In this way, means 2y square minus y square is y square, directly writing it, then plus 2xy minus of x square, okay, directly writing. After opening the bracket, you will get this one. This del z by del. Now, Here in this function, u is given in terms of x and y. Find double derivative of u with respect to y, double derivative of u with respect to x. Okay, so I am going to find out del u by del x first. Del u by del x means derivative with respect to x keeping y constant. This is the function of x, this argument, derivative of tan is sec square and derivative of y plus ax is a only because derivative of y is 0, derivative of ax is a plus this argument containing x to the power n derivative 3 by 2 y minus ax raised to power 3 by 2 minus 1, or you can directly write 1 by 2 multiplied by derivative of y minus ax with respect to x is minus a. Now try to simplify for one more step. A sec square y plus ax minus of 3 by 2a y minus ax power 3 by 2. Okay, now what I am going to do? I am going to take derivative of this once again because I want del 2 u by del x square. Or in this way you can also split this double derivative in this way and put down the value of del u by del x and go on solving. Or differentiate with respect to x keeping y constant. Again, keeping y constant. See, derivative of del u by del x with respect to x is del 2 u by del x square. Take derivative a multiplied by derivative of sec square is what? 2 sec y plus ax. Okay. And derivative of sec is what? Sec y plus ax into tan of y plus ax. Derivative of sec is what? Sec into tan. And derivative of y plus ax with respect to x again, derivative of argument that we have not written, multiplied by a. Now, minus 3a by 2, derivative of this term. The derivative of, we are taking derivative with respect to x. X is present in the base. Variable power constant derivative is what? 3 by 2 y minus ax power 3 by 2. This is 1 by 2, no? This is 1 by 2. 1 by 2. And 1 by 2 minus 1 is minus 1 by 2. Directly write it. And again derivative of y minus ax with respect to x is minus a. Okay. So you can solve for one more step. See, 2a. 2a into a is 2a square. Sec into sec is a sec square. Tan is as it is. Here, what? Minus minus plus 3a square by 4. A multiplied by a is a square. 2 multiplied by 2 is 4. And y minus ax power minus 1 by 2. Okay, this is del 2 u by del x square. Similarly, you can find out del 2 u by del y square and it is for you. It is for you. Okay, various functions we discussed and its differential coefficients we discussed. Derivative with respect to x, with respect to y, with respect to z, and all partial derivatives. Okay. So we stop here because this type of question, one question may be there in the examination, and unluckily, if the question is not there in the examination, this type of thing will be used in solving problem of the further part of the syllabus. We stop here. Thank you very much.